Happy Super Bowl Sunday, and thanks for watching. Today I'm working more on my model for the stock market. Real quick, I'll go over what I've done so far, where I'm at, and then I'm going to talk about what I did yesterday, and then we'll get into it. So here's my PowerPoint. And this is basically the summary to date. So I'll just just a sec. And okay, good. So first up here, data. I got data, cleaned it up, tested it. I'm looking at both data from NASDAQ, the NASDAQ website. You can download CSVs, but that's not good for automating things. So I also found a link to some data at DoltHub. I forgot to put it. I don't think it's in the description of the video, but if you go to the GitHub, which is in the description of the video, I'm pretty sure it's documented there. But I'll just let me just put that in the chat real quick if you're interested. Let me pull it up. DoltHub, post no preference. Okay, and this guy updates the data all the time. You can, there's some way to interface this if you pay from the terminal, but you can also just download it from the web. Let me put that in the chat. Yeah, so I got, so first I was getting NASDAQ data, then I got this DoltHub data. I had to do some things to clean it up and check to make sure it was good. Here you see I'm accounting for a stock split, so the price didn't plummet that day. There was a stock split, and so once I account for that, it's really smoothed out. I did some basic analysis. This is looking at fundamental variables for different stocks, and this is comparing stocks in a sector, in this case pharma, against each other and their performance against the average. That basically lets you see how well something's doing in relation to its sector. Then I built a LGBM model, so none of this is automated, won't automatically make picks. This will. And so I trained an LGBM model on returns, got about 51.5%. Then I kind of tried some portfolio strategies to plug this model into future data, get a prediction, and then based on that prediction, here's some different strategies. So this just gets the lowest 20 some odd in terms of volatility. This over here is interesting. I found that if I'm picking all 500 stocks from the universe and then ranking them, weighting them, and making picks, weighted picks, I'm underperforming the S&P 500. But if I only take the top 100, I'm matching the S&P 500. If I take 20, the top 20, I'm beating the S&P 500, and if I take the top one, I'm doing way better than the S&P 500. And so then I decided to look at how does that change the Sharpe ratio. We want a Sharpe ratio above 1. That's considered useful. If it's below 1, you don't want to use it. But ideally, you would like something more than just barely above 1. You want it well above 1. And so then I tested out different thresholds for the model. And here you see this is the performance. So I increased the threshold. If the threshold's 0.5, I'm just taking the best buy. But then if I increase it here to 0.53, you see the Sharpe ratio goes up. 0.54, it goes even more up. And so that's saying rather than just make the best pick every day, only make the best pick if it's above 0.53 probability of going up. And so with that model is this purple line. And so you see it actually looks like it's underperforming these other two models, but the data's from 24 and 25. And so that's basically a bull run with the tariff drop in the middle. And so we can, a riskier strategy should outperform this in the bull run. But also, what happens is if we go into a bear market, the purple line is going to be a lot more steady, and that's reflected in the higher Sharpe ratio. And so, what happened with this is, how do I go to the next slide? Yeah, so then the problem with that method is the structure is really bad. So I have various scripts to get the stock universe, a bunch more scripts to train the model, and then a bunch more scripts to define the portfolio strategies. And so what that means is every time I want to do a different method for getting the stock universe, or a different method to train the model, or different portfolio strategy to implement, I have to make new files each time. And this results in dozens of files, and it will quickly grow to hundreds and thousands of files, which is crazy. And so now I'm making a new method where I'm organizing everything into a single class. I already have the clean data from the last slide. I'm making some filter classes for filtering the universe data, and that's going into here. I also have the returns model. I should add something here, because right now what I'm building out is so I've got the stock universe done. Now I'm building out some functions some classes to implement different features that I might want to use for the model, and then targets that I might want to use for the model. And I want every possible feature and target beforehand. And then portfolio model. And so that's just going to be the portfolio strategy. So what's going to happen is this is all going to be contained in one or two files instead of hundreds of dozens. And then as this project grows, I can make a different analysis suite, and then I can just save the different sorts of analyses that I do, instead of having hundreds of scripts. So that's what I'm working on. I set these deadlines for myself. So by February 11th, which is 3 days, I want to have clean analysis done and working. I'm kind of behind on that, so this is the timeline for that. Like I said, I finished the universe class, and I'm still trying to build the model class. I'm now 2 days behind because I wanted to have that done by February 6th. And then I want to finish the backtesting portfolio class. Originally, that was going to be today. I gave myself 3 days of float in the schedule, so I could get a little bit behind. So I might have to revise this. So that's the progress I'm making. Okay, and these are the features and targets. So in green are ones that I've already implemented, and so I won't be done until this whole slide is green. So that's it for that. Let me move my image back down. Okay. So something was not working right in here. Test basic feature. Oh no, test basic feature is right, I think. You can see in the plot that at least those values are correct. So, the problem is that this is very slow. So let me pull up Google AI Studio. Yeah. Oh, I said this was working, but actually it's not. So the 5-day lagging returns should be 5 days behind the 5-day future returns, but it's not. And so the question is why. So let's exit out of that. I ran out of tokens. Okay, so clean analysis.py. I'm going to put some music in. Let me make sure I'm doing this right first. Young nigga get paid. On Lorenzo. Stay down, yeah, I'm talking 10 toes. Yeah. So the target is log return 5. Feature is log return -5. Probably a bunch of uncle, couple halves. Alright, then let's add the files. So clean tests, clean analysis, features. I done seen it all. Yay, stack 7 feet tall. Okay, we have okay, so I don't have lag returns in there. Oh wow, oh wow, oh wow. So one row, two columns. Let's do one row, or one row, one column. Let's make this one row, two columns. And then Chula. Alright, then we could do price axis 2 is equal to fig.add subplot. One row, two columns, second guy in there. And then we get log return axis. Let's also make volatility axis. Dot twin x. Okay, so now it should log by 6 days. Yeah, anyway, what I was doing before was training the model. In the scripts, I was training the model on I would add open price for the current data into the model, but that makes it so you have to get to open. So instead we want to pull the data from the previous day and then update before the market opens. Okay, so how is this different? So log return. Initialize it, same thing. Okay, so it's currently doing that. Instead, let's do brief close equals grouped close. Is it getting volatility or log return? Yeah, log returns. So if we have negative number of days, let it all work out. And then we get start close. So if we're getting a feature, do that. If we're getting a target, do this. Either way, future close. Let's call this end close. Oh, let me put another chat in the comment. Another comment in the chat. Where you from, young homie? Out the window, check yourself. Man, I need something good to listen to. I was looking at him different. That was back when I was 9. Joey packed a 9. Okay, so close will be that. Otherwise, if we're getting a target, And no matter what, it's just prev close divided by start close. So this should always be end close divided by start close. And I guess in tests, I don't want to add the second axis yet. One, one, one. Where's the plot? Okay, let's see. Is this plot correct now? Did I save this? Yeah. Just everything's going slow. I'm gonna see if I could exit out of some stuff. Don't need that right now. Sorry, I'm just saving some stuff really quick from work, but no, I can exit out of there, and that should be a lot faster. Okay, do we get the plot? No. The first one worked. But the second one isn't working. End close divided by start close. So group close dot shift. So end divided by start works for one, but doesn't work for the other. df, I mean, yeah, if I do df dot close, it won't be grouped. Hey, good morning, Terry. I kind of go over it in the beginning. Let me go over it again really quick. I'm basically trying to get a model for the stock market. This is kind of what the layout looks like. So I want to get a stock universe, which trains a returns model, which then is fed into a portfolio model. So I've defined the stock universe. Now I want to get a returns model. I've already kind of implemented this strategy here. So I've got, let me make full screen. I have data. I did a basic analysis, just plotting things against each other. fundamental data here, performance against the average in a sector here. Then I built an LGBM model. That's a light gradient boosting model. Basically, it's really popular method for stock returns because it's fast, it's effective, and it handles missing values really easily. Then I implemented that. So this is step one, the data, and then defining a universe. Step two is this build model, and then step three is this portfolio strategy. And I've got something that works, but it's really fragile. It only picks one stock per day, so I'm looking for something robust. But this is currently what I'm doing. So I have dozens of stocks to implement this, or not stocks, dozens of scripts to implement this. And I'm writing this all in Python. And the goal of this is to get something that works on the market, an effective model, while using free data. Because that's kind of something anybody can use and prototype with. And so this method is taking dozens of files. I'm going to build this new method, so I already have clean data, and I'm feeding in I built some filter classes to filter the stock universe, and then I built the stock universe class. What I'm doing right now is building feature/target classes. And that's for training the model. So your input to the model is called features. What your model's trying to predict, you call your target. I'm just kind of updating the PowerPoint real quick. Okay, so this is what I'm building right now, and that's going to feed into the returns model, which is then going to generate a model. And then that model that's generated here, I'm going to then put into the portfolio model, and I'm going to have different strategies for getting this to work. This model, and these models that I've trained here, the best I'm getting, these are just different portfolio strategies on this model. And this model is about 51.5% directionally accurate. So when this predicts a stock to go up, it's correct 53% of the time. Or if it picks it to go down, it's correct 53% of the time. And that's pretty good. 51.5, not 53. What I want is something that's correct 53% of the time or 54% of the time. So I need to do a lot of prototyping and look through what kind of matters for the model. But that's hard to do with the current method because I have so many scripts. So once I get all this combined into a concise class, then that will be easy to do. And like I said, I'm working on implementing the features. So greens, all of these are features that I want to add. Greens are the ones that I have. Although it's not working, so I'm trying to get it to work. So that's what's going on in this file. This is the features file where I'm defining the features for the model, and everything else is stored in here. But this isn't working, so I'm trying to figure that out. So let's say I implemented the class below. All right, so let me copy and paste the class. When I run, so I've already given it the clean tests file. Why do I get this error output? Okay. And I'm using Google Gemini Pro. That's what viewer recommended that to me, and that seems to be the best model for writing code that I've found. There's all the companies are constantly coming out with new models, but this one is really effective. Oops. I gave it the wrong class. And yeah, if you're interested in this, you could find the project on GitHub. I'm working on this every day and adding stuff regularly. It's kind of a mess right now, like I said. Eventually, I want to move all these files out. Like, you see how I have to do different versions for everything. So I want to get all the crap out of here. Analysis is a useful file. Dolt reader is a useful file. Features, clean analysis, clean tests. That should be all I have once this is done. In the else block, you assign group to close, which is a pandas group by object. Okay. But if the end close is grouped, I'm worried the start close won't be grouped. Won't this cause problems in getting the proper log return? The different stocks will talk to each other. Okay. So what if I just shift by 0? Oh, I thought your name was Terry, if that's you still watching. It's not Terry. I thought, that's a hard name right there. Hard last name. It's terrible at chess. Okay, so this is what I'm getting now. They seem like they're like inverse of each other. Oh no, this is lagging. This is yellow's future. So the lagging is still a little bit different. So we won't catch that when it takes off. We could just print them out since it's there's only 30 of them. So let me go back to tests. Print sub df dot this guy and then print this. And we should see that the feature is lagging the target by now 6 days. see if that works. I might print them independently. I want to look at them next to each other. I guess I could just print subdf. That'll be 30 values. Let me change it. Just say print subdf. Okay, so log return 5 days. So this is minus 0.003. Should be 5 days behind. So 6 days behind this. So in 1, 2, 3, 4, 5, 6. 64008. That's correct. And 0.014282. That's right. Yeah. So this looks correct. Here's what the plot looks like. Oh. So how many days is it? 1? This should come up in 6 days in the future. 1, 2, 3, 4, 5, 6. Yeah, that's correct. Okay. So now this guy works. Okay, so we finally do indeed have log return working. Volatility is not working though. So in get, we want to give the grouped close, log return. We can get rid of that. Okay. So we want to do the same logic in here, log return. That might be working because I wrote it yesterday. So let's see. Now we'll add in the second axis. Say fig size is equal to 10 across by 5 high. Okay, so we added a volatility target. Now below, let's do volatility feature. Set title. Okay, so instead of set title, do fig dot subtitle. And we'll call this testing classes in feature. Testing first two classes in feature. And then we could say price ax dot set title, and this is the log return. Price ax2 dot set title, and that title is volatility. So that's getting the I'm doing it for the first axis. Why does it look like that? Those two lines just continue. Oh, because it's 1, 1, 1. 1 row, 2 columns, number 1. And then I need to add the volatility plotting. Date versus volatility. 5-day return. Volatility, 5-day return. 5-day target. Oh, I think I defined this wrong. So volatility feature, yeah, should go -5. And then we do that, and then before showing, we want to say tight layout. Oh, I didn't finish this. So then subdf dot volatility 5-day target. Five-day feature. Label is lagging 5-day volatility. Okay, now we should be good. This is going really slow. I think it's because it's sorting the data frame every time. So I should make sure, check if it's sorted and only run that if it passes the check. All right, now here we go. Does this look right? Oh, I guess we really want to check in here. So 5-day target. .005388. All right, so this should be, the target should be really 6 days ahead. So 0.00538, so 1 day, 2 days, 3 days, 4 days, 5 days. But then here the feature is 1, 2, 3, 4, 5, 6. So this is looking God. It's looking good, but things are 1 day off. So let me think. If you want from the previous day to 5 days before that, that's the average over a chunk, and then you want the current day plus 5 days in the future. So the previous day will catch up with the future day in 6 days. So it's off by 1 day somehow. Dot shift. Six days, right? Yeah, it should be off by 6 days. Is the logic correct in my volatility class? I think the feature should lag behind the corresponding target. So, and then at one point, 1 day, 2 days, 3 days, 4 days, 5 days. Yeah. Should lag behind the corresponding target by 6 days. Is this correct? Here's the class. Here's the output in sub of sub df from cleantests.py. All right, let's paste this now. Ugh. That's why it's getting the current day's return. So if I'm not shifting, so if num, let me think through this. If num days is less than 0, the end I need a different song. My God, it's a nightmare. Okay. So we're doing the current close divided by grouped close dot shift 1. So that's fine. You just want the log returns. Roll in. Um, 5 days. A shift 1 when calculating the feature to exclude the current day. So if num days is less than 0, shift it by 1, and then get the rolling. But is that even right? Rolling standard deviation. Oh yeah, good, because window is the number of days. Okay. So if number of days is positive, shift by that. Otherwise, if it's negative, shift it by 1 to get the previous stuff. Every time that we hit them, good morning. Okay, so that's what the plot looks like. Now, does this look good? So these are good. Now this should lag by 6 days. So 0.002, 1, 2, 3, 4, 5, 6. Oh, that's the target. So it should, this column should hit this value in 6 days. So this is the value. 1, 2, 3, 4, 5, 6. No. President Carter. Oh. So these should be the same. No, still not the same. So instead of shifting by number of days, shift by 1. Because the base class pasted below sorts the data frame. All right, now let's look. So feature should hit this value. 1, 2, 3, 4, 5, 6. Okay, good. Now both of them work. Where is the PowerPoint? £140, 5'6" from the ground. Murder show. I give your ass good seats. They shoot missiles and nukes. Okay. So now I can go into implementing the other stuff. So first we want to implement SMA. Morning rain clouds. Oh, TA lib variable. My function. So get the function result. T's gone cold. I'm wondering why. And then we want to do the same thing. So shift by the negative number of days. Oh, let me see first. This means the data frame is sorted each time a new feature is calculated. How can I test for the data frame being sorted before sorting it? Is this logic correct? He used to always cheat on my mom and beat her. So this is after the test valid data frame. Well, I thought this would run way faster, but it's not so far. That was a little bit faster. Okay. I thought penultimate meant final, but now I'm not sure. Oh, second last. This is the final. I'm glad I inspire you, but Stan, why are you so mad? Well, I don't know. I don't really trust it. This stuff needs to be robust, so I have to build it myself. I have to go to the bathroom really quick. I'll be right back. Okay, I'm back out. Now what was I doing? Oh yeah. So let's go through the logic. Like auditors, told me that should be the same, and then get if self.name. Alright, I have that, my function equals that, time period. That'll be fine. Okay, so I can just say let's comment this out. Then I get the function. I'll just put that in there, why not? So calculate and shift. First try getting the function. And then give the series. Otherwise, so if the history is too short, if the history is too short, okay, so it's just calculating the result. Original values. Okay, so here I'm saying result. I'll just put that function in. Do I need to do this? Calc and shift. and then shift by the number of days. So do I need to specify the time period? So like moving average, for instance, it'll get the 200-day moving average. And then there should be a lag. Class should be flexible, and I want to do things like get the 200-day moving average with a 5-day lag for feature. I also, this class will not perform as I want. Is my logic correct? Okay, and then I just need to update that shift. Okay, and then we need to apply this logic. the 200-day moving average looking backwards. This actually might not do what I want. So finally, I want to calculate the 200-day moving average so x TP okay, so that should be in here. So if num days is less than 0, if a feature get up through the previous close. Average up through the previous day if it is a feature All right, now let's add another test in here. Fine. Oh, that's inside of calculate and shift. And then we can say if num days Not if numDays is equal to 0. If numDays is less than 0. Yeah. Forgot to add the files. That's true. Oh, here we go. Good. That was an error. Okay, so now let's test this. Then we could say feature. number of days is, let's do 5-day lagging, 50-day moving average. Var, so for each var in these, we're going to do var dot, what is it? Retrieve data, df, yeah. And we should see the features are lagging the target by 6 days. Okay, so 38.277, then we go 1, 2, 1, 2, 3, 4, 5, 6. 38.2770. So 7, 8, 9, 10. So lagging by 11 days. gonna run that again to make sure I saved it. One, two, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's wrong for some reason. Does that make sense then? The 5-day lagging SMA should be six days in the past. So if we want the SMA from 6 days in the past, and if as target, yeah, we don't want to include the current day. If we have the SMA from 5 days in the future, oh yeah, that is correct. No, that's not what I want. Target should be lagging. Oh. Feature should be lagging target by 11 days. Okay. So now since this class is working, I need to say next. I'm going to build build test for all functions in for all features / targets that can be calculated in TALib. Okay, so let's go back to the PowerPoint. And this should show back to the features. So we've added SMA. So if we want to predict, if we want to add as a feature, SMA from the previous day without a lag, that's something that I'm gonna have trouble with. So let's say we specify lag equals 0. It's not gonna work. Okay, so we'll only raise the exception if so we're initializing a variable, we're passing in the name. But then what do we call it? Oh, get detailed name. So the name isn't gonna change. Yeah, so we could say if name not in TALib functions, then raise an exception. Okay, so now we have all TALib functions. I'm just gonna see if I could find that command. So all funcs, I for I in all funcs if for func in all funcs print func.params. Oh man, okay. I could add that logic in later. Yeah, I'll save that for the next stream. So that's not done yet. So that will be the second to do. Update ta-lib feature / target class to get the values from the log return data instead of the close data. Okay, So that's it for today. Yeah, I don't really have anything else. Thanks for watching. Subscribe if you thought this was interesting. Go to the GitHub and you can get the code. Oh, I should update the GitHub. So we have clean tests. Fixed feature test added test for TAlib feature class. Feature class. Will I change anything there? Okay, good. Yeah, so now that's it for today. Thanks for watching. Hope you thought this was interesting. If you did, go to the GitHub. You can get all the code right here. Like you can see, I just updated it. And if you find it useful, please star the repository. So, adios. Thanks for watching.